Now students, I will explain another initiative theorem 1.4. Here one proof based question. We have to prove that root 2 is an irrational number. Remember, root 2 is an irrational number. We have to prove by contradiction method. So let's see how by contradiction method I'll prove you. This is a very important question. In many CBSE board exam, repeatedly this like questions is coming as 4-mark question. So be careful and understand the proof, how I am proving. Proof. If possible, let us assume that root 2 is a rational number. I said I'll prove by contradiction method. First, I will say that root 2 is not a irrational number, it is a rational number. That's why I said, if possible, let us assume that root 2 is a rational number. You know that a rational number can be written in A by B form, where A and B are co-primes. What is the meaning of co-primes? Co-prime means how A and B will be co-prime when the HCF of A and B will be 1. Then A and B are co-primes. That means no common factor other than 1. So root 2 can be written as A by B form because we have assumed here that root 2 is a rational number. Now root 2 is equal to A by B. So B will come to left hand side. Here it is divided. When it will come to the left hand side, you have to multiply. So root 2b is equal to A. Now squaring on both sides. So 2b square is equal to A square. That means 2 divides A square. 2b square is equal to A square means 2 divides A square. Means 2 is one of the factor of A square. How? Suppose I will say one example. 36 I can write 2 into 18. This one I can write 2 into 3 into 3 into 2. In like this way you can write. But I can say that 2 as 2 here multiplied. So we can say that 2 is one of the factor of 36 because 36 I wrote in the product of prime factors as by the definition of a fundamental theorem of arithmetic. Like that 2b square is equal to A square. This means 2 divides A square means 2 is one of the factor of A square. Previous theorem I explained, if P divides A square, then P also divides A. Similarly, if 2 divides A square, 2 also divides A. That means 2 is one of the factor of A. Again, let's take A is equal to 2C. Substitute this A value in this equation. 2b square is equal to A square. After substituting, you will get this step. 2b square is equal to 4c square. So b square is equal to, if we will cancel here, so b square is equal to 2c square. That means 2c square is equal to b square. I just reverse it. That means again I can say 2 divides b square. That means 2 is one of the factor of b square. Then 2 also will divide b because already I have explained this theorem. 2 divides b square, then 2 divides b. That implies 2 is one of the factor of b. Therefore, in case of both A and B, we are getting 2 as a common factor. But this contradicts our fact that A and B have no common factor other than 1. But here we are getting A and B have 2 as a common factor. So A and B are not co-primes. So our assumption is wrong. Root 2 is not a rational number, it is an irrational number. Clear? Hope you understood.